as I mentioned before, we don't really have a presenter for this paper, right? So no one volunteered. So I'm going to try to quickly improvise and kind of talk maybe somewhat broadly about the paper and the topic at hand, right? So this group of authors in this paper, they argue for the need for enforcing the consistency across multiple services or microservices in a microservice type application, right? So the idea is, if you have like a microservice type application, of course, like all of these microservices are somewhat loosely coupled, right? And they can use different storage subsystems, different storage services, and whatnot. So whereas like each particular microservice or service can have some notion of consistency internally, right? The application as a whole, composed of these microservices, may not, have the same notion of consistency, right? And according to the authors, sometimes that creates, a problem, right? So we like things to be consistent, right? And one thing that I didn't really like about the paper is, they don't really define, consistency that they're talking about in the paper, right? So, that being said, they talk about, having the causal consistency, right? So, something that is like externally observable, by the clients, in the sense that, if the clients perform some action, right, and then they perform another action in the future, if one action happened before another, then, there is a causal relationship that needs to hold, right? So they give one particular example of like where the consistency or the causality is somewhat broken in microservice type applications. So they have this example, which again, it's not really their example. I think they borrowed it from another paper, from another report, and somewhat simplified it. So if we have users, so in these examples, users, it's a social media type example. So they create some posts on the social media, right? So the user is going to talk to one service, microservice for the post upload. So maybe like the uploading pictures and whatnot. That microservice is then going to talk to the storage to make sure that the post is stored and replicated sufficiently in that region. Once this is done, it's going to talk to another service called notifier that will essentially send notifications to the users that, hey, this particular user has created a post, right? So and this order is kind of important, right? You don't want to notify the users about the post creation before it is replicated in a storage system. Otherwise, when the users try to retrieve the post, they may not get the data, right? So that will be like a really bad user experience. So that would be like violation of causality, right? So in this region A, there is a very like strict causal relationship. Upload first needs to do the storage, and once the storage is done, it talks to notifier service, and notifier service does the notifications. What happens with the users when so the notifier service is going to talk to another service like follow and notify, which will notify all the followers of the original like post original user who made the post, and this follow and notify service needs to retrieve the data from the storage, retrieve the post, and present it to the users, right? So this is kind of the workflow, the flow of this like post system. And they say that this can break if certain things happen, right? And those certain things are like if we, for example, distribute this system across multiple regions, but don't make the post storage service, the one that essentially preserves the post information, if we don't make it synchronously replicated across regions, right? In that case, what can happen is, once the notifier starts the notification, it also replicates those notifications, in its own storage or queue system and whatnot across regions. And we kind of have a race, right? So the post storage service, it has made the post durable in the original region, but it's also replicating it to other regions. And so is the notifier, right? It's replicating this notification to other regions, and these two are racing, right? And what may happen, like on the other region, for example, is that the notifier receives the notification, it gets replicated first, it receives the notification, it tells the followers, hey, there is this post with this post ID, and the followers go to their local copy of the post storage microservice, post storage service rather, and they don't see it because this replication hasn't happened yet, right? So the authors claim that this is a causal violation, right? So the notifier in a original like single region setup, can only do its thing after the post is durable and replicated in storage. But because of this race, right, you can end up in kind of a reversed order, right? So that the notifier gets the data before the storage does. So yeah, that's kind of the problem they try to solve. They did some experiments with this setup, and they on AWS with different like storage services and different services used for the notifier, and in some combinations they can see quite a lot of inconsistencies, right? So at least in their like toy example, those like races they do happen sometimes quite often, and yeah, so that's the problem they want to solve, and they want to solve it in somewhat generic and general way, right? So the authors argue that of course once you have this problem, you can solve it in some kind of ad hoc manner, right? So you can maybe make the replication to you can make the post storage service replication synchronous, right? But that's going to like add extra latency, but technically solve the problem. So yeah, one sec. Okay. So okay, what do we do then? So a good chunk of the paper talks about how can we keep that causal information, right? And how can we propagate it in this kind of microservice type scenario? So the authors talk about lineages, which essentially tries to capture all of the causality, even for things that under a normal extended definition of causal consistency will not be causal, right? So if we again kind of try to imagine this scenario, we had this race, the replication race going on between the notifier service and the post storage service. The notifier directly calls like the fact that we write to the notifier directly causes the later read, right? Like when you dequeue. So there is like a causal, like a standard causal relationship in that regard. But when we try to read the post, this kind of happens in parallel, right? So the kind of the initial order of operations was only replicate in a single region before doing the notifications, right? So the replication across regions, it's kind of it's not in a linear path of that's service A, the notifier service. So the fact that this replication happens across regions, it's actually not in a kind of causal chain. It's concurrent to anything else that may happen here. And they say that this obviously concurrency, that's the race that they want to fix. So they want to propagate some information in the entire kind of tree of like microservice calls, right? And not only calls, right? So it's one service calling another service, but also they want to replicate this causality as it travels inside the storage systems, like in this case, inside like a replicated data store, right? As it replicates from one region to another. I'm not sure they do like a lot of really super new stuff here, because all they do is they propagate the kind of version numbers for for the objects that they work on across the call stack, right? The only kind of additional thing that they do here is they add the shim layer in front of all the stateful services like database and queues and whatnot, to make sure that the same causal information, like the versions and whatnot, they get stored in those systems, right? So their solution is pretty much just store the versions of all the objects they work with in those kind of, they call them lineages, right? So whenever the second lineage starts this read Y and in second request, if it has the dependency on the previous one, then it will have the dependency on everything. So it knows that Y was dependent on the post storage service to complete. So that will be written in the lineage that this request got when it read Y. So when it needs to read X, it will know that, hey, I need to expect the version of X to be a particular value. So I will bury until that happens, right? So that's kind of the solution in a like very high level, in a very high level terms. Yeah, so they claim that what they do is kind of more general, because they can propagate this kind causal information like almost automatically, right? So like the versions and whatnot, it requires very little programmer intervention, right? Or like changes to the services. I think the biggest change that they like impose is the requirement to have shim layers in front of the databases and storages, so that along with the object they store this lineage information about like what objects they are accessing at what versions. There are a few like other optimizations that they do, so they don't actually try to track everything, because they claim that for like really large systems that will be a lot of dependencies to keep track on like all the services and objects and everything that happens. So they led the programmers to kind of narrow it down and only track things that matter, right? So they, for example, may identify that this race is common, that happens a lot, so they're gonna track specifically things for like object X and propagate that information, but they may not worry about some other things, right? So yeah. Yeah. For their evaluation, they implemented that example, they tried it again, and they also tried a few like microservice benchmarks. Yeah, I guess the point that they want to convey is their solution doesn't slow things down too much, while offering better consistency. So based on this kind of latency, throughput, it seems almost the same, even though in my opinion doing 140 requests per second is kind of not very impressive in 2024. But yeah.